Hello everyone and welcome back to another video. This video we're going to be going over SHSAT math, percentages, and probabilities. So let's go to the first question. So in this question it says, a survey asked students what pets they have. Based on the results, the following statements are all true. So 20 students have cats. We have 23 students have dogs. We have that 3 students have both dogs and cats, and 5 students have no dogs or cats. So this is the type of question where we actually need to draw a Venn diagram. So it's going to look a bit like this. Like that, and like that. And this circle right here is going to have dogs, the students that have dog anyway. And this circle is going to have cats, the students that have cats. And this intersection is going to be the students that have both dogs and cats. So using this piece of information, it says 3 students have both dogs and cats. So we're going to put number 3 here. And when we fill in this information, we actually have to take into account that these 3 students that have both are actually going to be taken into account. So including the 3, that would mean 17 students would be precisely in this area. So as a total, 20 students would have cats. But 3 of them would have both dogs and cats. And now we do the same thing for the dogs, except this time we have 23 people that have dogs, and we would have 20 students here. And in total, again, 23 total students would have dogs. And outside of this, we would label this as our entire data set. 5 students fall into neither of these categories. So how many students were surveyed? We made sure that there was no overlap, so that would give us 5 plus 3 plus 17 plus 20. That would give you, this is 8, that's 37, which would give you a total of 45 students surveyed. Alright, great. Let's move on to the next question. Let's erase this first. In this question, it says people per vehicle at checkpoint, and it gives us some percentages with some data, and it says researcher recorded the number of people in each vehicle, and there's a total of 420 vehicles, and how many of the 420 vehicles contained at least 3 people? So at least 3 means greater than or equal to 3, so that means that both all of 3, 4, and 5 or more are all considered to be part of what they're asking for. So we have to add these percentages because they all correspond. So we get 3% plus 7 plus 15, which gives us 25. So this is a percentage. So, and now this is the total percentage, and we're taking that percentage of the total. So the total is 420, so we have 25% of 420. Sorry, percentage. And now we're doing 1/4 times 420. And if we do that, we will get 1,4,0,0,0,2,0,5. We get 105, and 105 will be the answer, G. This one, where it says, in Centerville, 45% of the population is female, 60% of the population commutes to work daily. Of the total Centerville population, 21% are females who commute to work daily, and it asks for this. So this is the type of questions where it gives you 2 total criteria, and you can be either female or male, and you can either commute to work daily or you do not commute to work daily. And that's why we're going to draw a table right here. So not daily and daily, right? And here I'm going to do F and M to signify female and male, right? So we're going to do 45. Oh, and also let's not forget to add totals. So the total here, total, and the total here, total. So of course the total of everything in terms of percentages is 100%, So this would be 100% at the corner of everything. And it says that 45% of the population is female. So that means the total female population is 45%, so that goes here, 45%. Now, of the total Centerville population, 21% are females, so they're in the female category, and they commute to work daily. So that means that this right here, because that fits both criteria, that would go there. And now that we have this information, we know that using that the female row has to add to 45%, we know that this has to be 24% because 45 minus 21 is 24%. Now this and 60% of the population commutes to work daily. So that means that this column right here would have to add to 60, giving us 60 minus 21%, which is 39%. 39%. And here we're going to have, well, of course, female plus male must add to 100%. 100% minus 45% is 55%. Okay, so now let's go and we can say that the total here would be 40% because the totals must add. And here we can do two different ways, but 24 and 40, so this must be 16%. And it asks what percentage of the total Centerville population are males, so in this row, and in this column, so 16% is the answer to this question. Moving on to the next question, it says here a box of colored pencils contains exactly 6 red pencils. The probability of choosing a red pencil out of the box is 2/7. How many of the pencils in the box are not red? Okay, so we have 6 red pencils, 6 red, and we know that there's a 2/7 chance of choosing a pencil that is red. So 2/7. And what we're going to do actually is we're going to scale this ratio up, because if you think about it, this probability is just a ratio between the number of reds and the number of totals. So if we scale this up, we want 6 in the numerator because there's 6 reds, and that would give us 6. And then what we did here was we multiplied by 3, so this would have to correspond because what we do to the top we also do to the bottom, so this would be 21. Okay, so we now know that there's 6 reds, which corresponds to this, and there's 21 total. How many of the pencils in the box are not red? Well, there's either red pencils or they're not red pencils. So to find the number that are not red, it would be 21 minus 6, which would equal 15, giving us B as the right answer. On to the next question. In a sample of 10 cards, 4 are red and 6 are blue. If 2 cards are selected at random from the sample, one at a time, without replacement, which is very important, what is the probability that both cards are not blue? Well, we have 10 total cards. We have 4 red, 4R, let's say, and 6 blue, so 6B. Okay. One at a time without replacement. Without replacement means that once you take out the card, you leave it out for good. So you're not considering it in the next iteration of taking it out. So on the first iteration of taking out the first card, it would be, what's the probability that both are not blue? So what's the probability that the first time you draw it's not blue? Well, there's 4 reds and 6 blues. So the probability of taking out one that's not blue would be taking out a red, which is 4/10. And then, now that we know that it's without replacement, right, the total number of cards would decrease from 10 to 9. And the total number of red cards would decrease from 4 to 3 because we took out that red card. So now, on the second iteration, we would have 3/9 because there's 3 red cards left and we still want to draw one of them. So this is equal to, if we simplify this fraction, we get 2/5 times, and then 3/9 simplified is 1/3. This is equal to, we multiply the numerators and the denominators, 2 divided by 15. So E is the answer to this question. Now on to the next question. How people get to work in Center City. So as you can see, carpool 15%, bicycle 4%, walk 22%, bus 10%, drive alone 49%, and the total population size is 15,000 people. So how many more people in Center City walk to work than ride their bicycle to work? Okay, so walk is 22%, okay, and ride their bicycle is 4%. So if we were to find their difference, since we're taking this, the different percentages of the same thing, we can actually do 22% minus 4% to find the difference between them. That's 18%. But what are we taking 18% of? Well, we're taking 18% of 15,000. So we're going to do 18% times 15,000. So the 18% is actually 18 over 100 times 15,000. So we cross out these zeros along with these zeros, and we're left with 18 times 150, which I like to think about it as 9 times 300, because we're simply dividing this by 2 and we're multiplying this by 2, which makes the numbers easier. And this gives us a total of 2,700 people in terms of the difference, giving B as the answer.